Today we're going to talk about heap properties. First, the heap has to be a complete binary tree. Um, a binary tree is a tree um, with the leaf from the left to the right. Um, that is also called a structural property. Um, and the heap also has its heap order property, meaning the parent of a node is greater than its children. Let's look at the one graph represent a heap. And here we got a maximum heap, meaning the parent is greater than its children. 10 is greater than 8 and 7. 8 is greater than 6 and 4. 7 is greater than 5 and 0. 6 is greater than 2 and 1. So that is a heap that satisfies two properties. So we're going to talk about operations on a heap. Um, First is top, which simply returns item with the highest property, which is easy. And also we have insert operations on the heap, which means we insert one item onto this heap. If we use array representation of this heap, um, then we take the first step, which add this item to the last index in the array, resize if necessary, and second step of insert is bubble up or percolate up, because the item we are inserting at lowest level may change the property of this heap. So in order to maintain the heap property, we have to bubble up from the lowest level of the heap. And here is the pseudocode for bubble up operation. And first we start at the element we are trying to insert into the heap, which is at index. Then we iteratively swap this element with its parent. And here is the actual code you can refer. We can use index and -1 divide by 2, and we get a parent. And while we're gonna check the index is not at the root, and the array of this element in the array is greater than its parent, then we swap the element we're inserting to this heap with its parent. And after which we're gonna update the index and its parent. That's the algorithm for bubble up. Next, we're going to talk about pop, which removes the item with the highest priority. We also follow two steps. In the array, we overwrite the first item with the last item in the array. And since because of this overwrite, the heap property at the top may be disturbed, so we need to follow the second step, which is bubble down, also called percolate down. Here is the pseudocode for bubble down. So while this item is not at the last level, which we typically start at the root of this heap, we set the children node to the larger value. Or compared with two children, we take the one with the larger value. If the index is smaller than the child, meaning if this pair is not maintaining its heap property, we swap the item with the child. Else we do nothing, and we keep updating the index and the child. Here is the code that you can refer to, and if you're trying to delete or pop the element from the heap, you can calculate the index of the child by using the index multiply 2 and plus 1. You can get the child index, and in the while you're gonna check the if the child is less than the size of the heap, and you go into the while loop, and you make sure it won't go beyond the size of the heap by adding 1 to the child. Then you're gonna compare the right child with the left child to see if the right child is greater than the left child, and if it is the case, then you increment the child which represents the right child with greater value, and you compare this bubble with its child. If this bubble is less than the child, then you're gonna swap the child with this bubble. So if it's else, then you do nothing. Then you update index and child. And the assumption for this code is the index start from 0. And we're going to talk about efficiency of the operations. Top, which returns the highest priority item, which is 01, which is very simple. And insert, worst case, you're going to bubble up to through the entire path from the leaf to the root, which takes log base of n, log a base of 2 of n, and in average case it needs to be bubbled up at least part of the way from the leaf to the root, which also takes log n. And we're looking at the efficiency of pop operation. In worst case, it needs to bubble down the entire path from the root to the leaf. In average case, it needs to be bubbled down at least part of the path from the root to the leaf, which also is log n. we have to mention that there are two types of heaps. Mm, The first type is called max heap, which has the highest priority. Um, the largest value at its highest priority. And there's another kind of heap, uh, large, which means the largest priority is the smallest value. Uh, there are disadvantages of heaps in cases that you are trying to find lowest priority item, which takes O of n operations to achieve that.